everyone, let's get going with the learning for today. So what are we going to talk about? So we've been talking about circles, and we've been learning all sorts of interesting things about circles. And today we're going to focus specifically on circles and the relationship between circles and what we call tangents. And a tangent can be visualized like that. Okay, it touches the circle at just one point. Now, I want to know what is, in the chat, what is the green line called? So we know the one that's just touching, that's a tangent. But what is the green line called? Can we light up the chat, everyone? Yeah, so if this is the tangent, this is the radius. So that's one of the relationships that we haven't really given much attention to so far. Most of our attention has gone to the center of the circle, or what we call cyclic chords. Today, we're going to really look at the relationship between tangents and radiuses. And then I also want to ask you, if I have this outside a circle and I have this situation going on. So let's say, looks a bit strange, but you're going to see the shape today. We call this tangents from a common point. So if there's a point outside the circle and two lines come from it and they both just touch the circle at one place, these are called tangents from a common point. And the common point is this, and this point over here is called the point of tangency. So the one there, and this is also called the point of tangency. Okay, so that's a little bit of vocab that's new for today. And then one more little picture that I want to outline for you is, we said earlier on that this was a tangent. But what if I draw a line from here to here? What is this pink line called? And I'd love it if somebody could put that in the chat or raise their hand and they could tell me what the pink line is. Who feels like they know what the pink line does? Sipokazi, Laviwe, Michla, Ayole. Okay, people are saying that they know what this is. This thing is called a chord. Agreed. So if that's a tangent, and that's a chord. Okay, one more thing. Now, this is for serious brownie points. If I take that chord and I use it as a base, and I do this, can somebody come online and tell me, what am I doing when I use that chord as a base and I make that pointy bit at the circumference? What language could we use to describe that? Anybody feeling like they could give it a go? I'm not even worried about getting it right. I just want to kind of hear how you would describe what I did there. Who can try and put some words on, like almost like I built something on the pink chord there? Okay, it's a bit of a tricky one. Give a little bit more time. So what with the fancy word we say here is that the chord, a one, there we go. The chord subtends an angle at the circumference. So the angle at the circumference is this one here. The chord is subtending or building the angle. We're using it as the base. And this is called the angle at the circumference. And so today, we're also going to investigate the relationship between tangents, chords, and angles subtended by chords. So this is just an overview to get us going. All I wanted to do was make sure everybody knew the vocabulary. Can you give me a thumbs up if you feel like you know the vocabulary or you know the words that I've talked about here? You don't have to understand everything, but I just want to see if you understand the words I'm using. Thumbs up for yes, I know. Thumbs down for goodness gracious. Keep those thumbs coming. Let the people speak. Okay, cool. So there's a bit of a mixed thing there, but yeah, it was helpful for me to see kind of what is going on. So here is what I want to show you today. Here is the first fact or the first theorem for today. And so for those who are feeling like they don't understand the vocabulary, don't worry. We're going to talk about this now. If we look at this circle, what is this line that I'm pulling back and forth with I'm moving it out? What is that line called? For all those students who are struggling with vocabulary, what is this line that I'm making long and short? What's that called? Okay, so that is called the tangent. And the line that comes from the center to the point of tangency, what is that? What is this line over here called? Okay, so here's a tangent and here's a radius. Okay, so those are the two words. Now here, I want to show you something quite cool. Watch this. We are going to go on a little journey around, well, making the circle bigger and smaller. And I'm basically keeping the line on the outside a tangent. I'm also making the circle bigger and smaller. And I'm also moving it around. What do you notice about the relationship between the tangent and the radius? Who would like to come online and describe what they see? Do we have any hands? Karabo, let's go to you. Can we unmute Karabo? Let's see. Can we unmute you? Maybe we can
audio
unmute Faith.
Is not connected, Mr. Ace.
Okay, we'll go to Faith then. Faith, what do you think? What do you see here?
Hi, sir. I think it makes a 90-degree angle.
Yep, it looks like that to me. Or we could say perpendicular is another word, like Temi said. But basically, this is rather
yes,
interesting relationship. So this is going to be one of the cool facts that we're going to learn today. So thank you, Faith. So let's see how we might apply this to a question. So let's go to just question number 1. So I want everyone to have a look at question number 1. And you have to find me the value of the letter A. And all you're going to use is the that fact that you've just seen now. We call it the tan radius theorem. You don't have to write it down, but the tan radius theorem says that the radius and the tangent will meet at 90 degrees. So Brighton, I use a combination of questions that I think are suitable for the stage of learning we're at. So once we get through kind of the building block phases, then we get to more complicated questions. But to start with, I'll always start by building up. Yeah. Okay, people of the class, try and find me, if you use what we've just looked at, can you find me the value of A or 4A? So we're just focusing on question 1. And give it a bit of focus there. I'll zoom in so it gets your whole attention. There we go. And if you feel like you might be able to give us a tip or but ask yourself, what do you know for sure first? So I see a couple of people are saying 18. Some people are saying 54. Some people are saying 22.4, so that's good. There's healthy debate. Who would like to explain how they got there? So I see 54s and 18s. I see a 60. Oh, I'd love to hear a student explain their thinking. What thinking did you go through as you attempted this question? Okay, let's go to Umta. Umta, what tell us your thinking as you did this question.
Afternoon, sir.
Hey, Umta, good to see you, or good to hear you.
How are you?
Yeah, no, I'm good. I'm good. Tell me what you were thinking.
Sir, firstly, I subtracted 90 from 180 since a triangle is equal to 180 degrees. And using the theorem that we just did, I know that that angle is 90 degrees.
Okay, so you saw that this was a tangent. So this thing was a tangent. And then this thing was a radius. So you knew that had to be 90. Okay, and then?
And then I said 5a, which is the 4a plus the other a at C.
Okay.
Yes, I said that 5a is equal to 90. And then I divided both sides by 50. By 5. And then I got 18.
That looks good to me. So you know that would be 18 and then 4 times 18. So what would it be? 18, 36. This would be 72 degrees. Yeah, I like that. I think that's good.
Yes, sir.
Okay, so let's try another one. Or actually, let's just wait for a moment. Are there any questions? Or can you give me a thumbs up if that made sense to you now? Thumbs down if you felt a bit unsure. Just want to get a quick all right. Why don't we try and do question number 2? Now, question number 2 it's got some stuff the same, but it's got some stuff that is a bit different. And again, take as much time as you need. We're just trying to understand what is X, Y, and Z in this particular question. So we're trying to find out what X, Y, and Z is. You try and work it out. Now ask yourself, where can you use the tan radius theorem that I showed you? Is there a tangent? Is there a radius? And then ask yourself what else you might be able to work out. What other properties of circles might come in handy here? Okay, for those who are feeling a bit confused, don't worry. We just keep practicing. But the main goal is we're trying to find what X is. We're trying to find what Y is. And we're also trying to find what Z is. And they've given you some information, like you have a circle and you have an angle of 50. But what other relationships can you use in this question? Temi, do you want to share your thinking? Like, what was your thinking as you went through this process? I'd be super curious to know. Because like in maths, like I say, like a good show doesn't just have a good ending. You have to tell us the story along the way. That's where the real drama is. So tell us your thinking if you're able to, in terms of connections and stuff. So I see Temi, Annie's put an answer in there. Who else would like to let us know what they're thinking, what numbers they got for X, Y, and Z? I'll give you a little hint. I see a tangent going like this. And I also see a point of tangency over here And then I see a radius coming from here to here. So that's the sort of stuff that I would initially have a look at. Now, I do think there's a 90 here, but I don't think the 90 is just y. I've just noticed something else. Maybe somebody else can notice this. What are these two things with two lines on? Why have I put two little whiskers on them? What am I trying to communicate there? Aha. So Faith has said 180 minus 50. Faith, do you know what's going on with my whiskers? Ellington, I said they're equal. Brighton says because they're equal. My question then is, why are they equal? What has caused them to be equal? Tumaleng thinks they're equal. Absolutely. I think you're right as well. But the problem is in maths, we have to justify our thinking. So I agree the two whiskers, I was telling you the two sides are equal, but why are they equal? Who would like to tell me? I know there's someone out there who is just biting their lip to share their answer. So you're right, the triangle adds up to 180. But didn't we talk about these earlier in the lesson a little bit? What are these two lines? What are they both? Yeah, Mbali said they're an isosceles triangle. And the reason is these are both radii. So they both come from the center of the circle. So they must be equal length, which means that this angle over here and this angle over here must be equal. So what we're going to say is we're going to go 180 minus 50, which is 130, which is what, I think, who was it who was saying that? It was Faith, huh? Yeah. So now we've got 130 left in this triangle, but we have to share them equally between the one blue dot and the other blue dot. So we go 130 divided by 2, and we get 65 degrees. So y is going to be 65 degrees. What do we think z is going to be? I'll even write it here. So y is 65. This is 65. Who wants to come online and tell me what z is going to be? I know there's somebody who wants to share their knowledge. Because I feel like there's a right angle there somewhere, but then how is that connected to the 65? Okay, Annie's had a answer. Does anybody else? Yeah, let's go to Annie. Hi, Annie. Can you hear me, Annie? Yeah, I think maybe having some audio issues there. So Neliswe and Michla, so everyone is saying that this is 90 degrees because of the tan radius. And so whatever's left behind, basically, the Z is going to be 90 minus the 65 that's there. So it's going to be 25. And so Z is going to be 25. Now, this one down here is also going to be 65. So what is the X going to be? That's the final bit of answer that we need to get. What is the X going to be at the bottom here? How can we can zoom in on this just so we get a little bit more attention. Aha. So Wam and Annie and Michla have said 40. would anybody like to explain how they got 40? I think there's a couple of ways we could get there. But who would like to share their thinking? Otherwise, I will explain, but it's always nice to hear from a student if they feel they can share their thinking. Yeah, let's go to Vivian. Hi, Vivian. Can you hear me?
Hello.
Hey, Vivian. What were you
How are you?
thinking about when you got 40?
Yeah, okay. For number 2,
Yeah.
can you explain the rule where the tangent and the radius equal to 90? Why don't
Yes.
we make the whole triangle, like put it together, and then
Okay.
we can say 90 degrees minus 180 minus 50, and then
Yes. Oh, I see what you're doing. Okay, so you're looking at the whole big triangle. Like, are you looking at, excuse my horrible drawing,
no, it's okay.
are
Sir.
you looking at that one?
Yes, sir.
And then you're saying 180 minus the 90 for the bit with the tan radius, and then minus 50 for this one down here.
Yes, sir.
Okay, perfect. Vivian, I completely agree with you. So Vivian's answer 40 is correct. The other way you could have done it is to say exterior angle is 65. And so the sum of the interior opposites, so like what plus 25 gives you 65. But I think most students would have used the big triangle. So that's awesome. Oh, no problem, Annie. Don't worry. That's how technology goes. But we really appreciate your getting involved anyway.
Thank you, sir.
Thanks.
Question,
Yeah.
one more question, sorry. But
No, it's
also
fine.
for y as well. Why
Yeah.
can't you say that 90 equals y?
All right. The reason, it's a good question. The reason you can't say that, let me just clear this away, is y isn't the whole angle. Can you see how, like, y is just a piece? So there's an
Yeah.
extra bit below y, and together green plus blue give you 90. But y is only blue.
Okay. Yeah.
Does that kind of make sense? Maybe if I zoom in a little bit more, you'll see what I mean. Like,
No, sir. I
if you look,
understand.
you got it.
Yes, sir. Thank you,
Cool.
sir.
Pleasure. Okay, now let's do one more, then we're going to have a break. I want you to find me. So here's a circle. I want you to find me the value of E and the value of C. And this is a bit of a sneaky one, but not too bad. So find me the value of E, which is this little one out here. But if you find that, I'm sure you could find what 5E and C is. Let's give it a go. Go for it, team. I'm going to get some water while you go for this one. Okay, so if you find E, remember to put it in the chat, and then also try and find C if you can. I think a lot of students are noticing that they know that this is the tangent and this is the radius. And so this angle over here, this whole angle has to be 90. And so we go E plus 5E is equal to 90. So that looks, let me just do this again. E plus 5E is equal to 90. So 6E is equal to 90. And I divide both sides by 6. And I get 15. And so this angle out here is going to be can you, okay, I think everyone can see. Just maybe confirm. Label, can you see my writing okay?
Yes, Mr. S, we can see it okay.
So if E is 15, then 5E will just be 5 times 15, which is 75. So this angle here is 75. I want to know, before we go for our break, what is going to be the angle C up here? Who thinks they know what the angle C is going to be? Can you see what C is? So Ayole, at the beginning, the one angle is called 5E. So because it's 5E, we need to multiply whatever we got for E by 5. That's why we're multiplying. And E was 15. So that's there. And then the 5 is because of this 5 here. I'll give you another hint with this one. There are whiskers involved. So these two lines that come from the center are called radii, which means that this is going to be 75 and this is going to be 75 because it's an isosceles triangle. And then C is going to just be 180 minus 75, which is 30 degrees. So just a reminder, the real focus that we have at the moment in our lesson is understanding the visual patterns. In a formal assessment, we do also provide reasons, but again, it's easy enough to learn the reasons once you understand what is going on. The real focus today is just on understanding these new visual patterns, which, yeah, I think we're making good progress. But we have now been working for a solid half an hour, and so it is time for you all to turn on your cameras if you haven't already, and to stand up with me and to stretch your body out, because our brains were not built to just sit. And so what we're going to do is we are going to, turn on those cameras. Let me see your lovely faces. And I will...
Mr. S, my devices are acting up, so I can't put on my camera at the moment.
No, that's fine. Okay, what I want you to do is I want you to just stretch your neck to one side. 1, 2.
Please join in, guys. Give your mind a break.
Give that neck a good stretch. And then small circles are appropriate for this unit with your arms.
With the circles.
And then bigger circles, bigger radii. And by the end, it's like you're doing the not the backstroke, the butterfly, which I was never very good at, but we can all try. And then let's swing from side to side. You should hear your sort of lower back clicking a little bit. And then let's stretch out our arms a little bit. 1, 2. And switch. And just roll your shoulders back 10 times. 2. Okay. And then we're going to just get something to do, get our heart rates up. What we're going to do, oh goodness, must make sure I don't injure myself. I was going to do knee highs, but oh my goodness, that's too much. Let's stay with jumping jacks for today. Okay, we're going to do 10 jumping jacks. They go like this. 1 and down again. So we do 10 now. Let's go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that's just to get your heart rate up, and then just shake it out to finish off. So shake out your hands, get the blood flow moving, shake out your shoulders, and then sit down. And yeah, that, I promise it may feel a bit strange, but your blood flow does help with understanding, or it helps with learning, basically. Sitting for too long in the classroom, I'm sure you've all been there, where your brain just stops working. Let's quickly do a little puzzle. So here's my little puzzle. I add 5 plus 9 and get 2. The answer is correct, but how? So how do I add 5 plus 9 and get 2? Who knows the answer to that? Put your ideas in the chat. And then Atule, I see, is there a question there, Atule?
Yes, hello, sir.
Hey, how's it going?
I'm good. So I would like you to go back on those circles.
Yes, I'll go back in literally 30 seconds. We're going to go back and we'll have a look. I just want to quickly do the brain break, but stay on the line, Atule, while I wait for. Okay, I'll give you a tip. Here's my tip. Oh, wait. How can I add 5 to 9 and get 2? Do you want me to give you the answer? Or has anybody got the...
Other people giving up already, throwing in the
Yeah.
towel.
Okay, Umta, what do you think the answer is?
On time. And I know it's time, right? I don't know if I should say clock or something, but if it's 9 o'clock,
Yeah.
5
Well
hours,
done.
you-
So here's 9 o'clock, here's 2 o'clock. So if you add 5, 1, 2, 3 hours gets you to midnight, 4, 5, it's a clock. Yes, well done. Okay,
Well
everyone,
done, guys.
I thought that was pretty good. Yeah, you can use that with your friends.
Yes, that's a good one.
Okay. So, Atude, you were asking a question. Do you want to?
Sir, I would like you to repeat the E plus is equal to 90. This one, the bluish
Yeah.
one.
Okay. So, if you look at this thing we start with, the main idea is: do you agree that this is 90, the red bit?
Yes, I do.
Okay, so then you think about, well, what makes up that 90? There's the 5e over here, and then there's the one little e over here. Are you okay with that?
Yes, I'm okay, sir.
So then this is the green bit, and this is the blue bit, and they must be equal to 90. So that's why it's 1e plus 5e gives me 6e.
Okay.
And so now if you have 6e equals 90, you divide both sides by 6. And if you divide 90 by 6, what do you get?
You get 15.
That's good news for me. So you get 15. And what that's saying is it's saying that this over here is 15. And then the green bit is just, sorry, the blue bit is 5 times 15, which is then 75. And together those give you 90.
Oh, okay, I understand. Thank you.
Perfect. Pleasure. Okay. everyone. So the first part of today's lesson was about what we call the tan radius theorem, and we absolutely will work that in again. But I want to introduce one new type of theorem, and this will be the only extra new stuff from today. And let me just show it to you here, if the computer is behaving. All right. So who would like to explain to me? Who would like to explain to me what is going on? Actually, let's have a look at this first. Let's move it around, have some fun. I kind of enjoy this, I'm not gonna lie. Who wants to explain what is going on in this theorem? Vivian, let's go to you.
Hello, sir.
Hey.
So isn't it like tangents that equal to each other?
Yeah. So tangents. Yeah. Okay, I see a couple of things in the chat. I've lost you there, Vivian. Are you still with us? Or is it me? My internet connection is unstable, it says. Okay. So you were saying a tangent. Okay, so a tangent from a common point is going to be equal in length, is basically what this is saying. I know I haven't drawn my drawing perfectly, but basically we have some more whiskers. So in this situation, look at how the distance between the point, the common point and the point of tangency is always 142. But if I move it nice and close, even though the distance is different, the two lines are still an equal distance from the point of tangency. And so we call this the tangents from a common point theorem. And let's say, look, we move it up here. Let's even say like down here. It's still 157 units between this point and the point of tangency, and the same on this side. So it sort of looks like some tweezers or like a thing trying to catch something, like boop, boop. So let us see an example of this. Let me see if I can zoom up for a second. Do I have that? Let's have a look at question 4. Question 4 and 5 even. So if I look at question 4, yeah.
I'm sorry, there's just something in the chat here that caught my attention. Can you please explain why those points are not parallel? Those lines,
Okay.
the tangents.
Yeah. So when two lines are parallel, they're equidistant from each other. So I'll give you an example of parallel lines. They normally look like this because they're equally far apart from each other if you're perpendicular to them. So this would be parallel lines. If you look at these two lines here, so this tangent here and this tangent here, they start off quite close together and they move further and further apart. So these lines are not parallel to each other, but they are tangent from B. Okay, and they never touch except for at B. So what I was thinking is, could you guys, using this new idea, could you try and figure out what F is? So you know that from what we just said, this one over here is going to be equal to this one over here. So we're going to have some whiskers, or we're going to have an isosceles triangle. Can you work out what F is going to be? Now be careful with this one. See a couple of answers coming in. Who would like to explain how they got F? I see some good answers coming through. Mbali or Ayole, or who would Who would be willing to share their thinking? Koketso, Joy. Let's go to Joy or Jay.
Hello, sir.
Hey, is it Joy or is it Jay?
It's kind of both.
Oh, Joy Jay.
Yeah.
Awesome. Tell us your thinking.
So I kind of know, and that's triangles angles in a triangle are equal to 180. And then
Okay.
I took 180 minus the 80 that I already see here.
Okay.
And then I got 100.
Okay, so you took this one out of the equation. You took that away, and now you've got 100. How do you
Yes.
get to F?
And then I said 100 divided by 2, since these two sides are equal.
Yes. So this one over here and this one over here will be the same. So you can
Yes.
divide by 2 to get F.
Yes.
So did you get 50?
Yes, I got 50.
Awesome. Love it. So I agree with you. The answer to F is 50, and this would also be 50. Now, while I've got you, George, do you have any ideas? We've got F. How
Yeah.
would you start to head towards G? Can you give us a tip or any thinking that would help us?
I'm thinking of the subtended rule angles.
Okay. So subtended, not too bad. Let's see if anybody else can give us a tip. But thank you. That was awesome. Very, very
problem.
cool.
No problem.
Timmy, let's go to you. Timmy, what do you think? What little bit of extra info do I need to get me to G? It feels like G is in the promised land and we need to get there, but we're not far away.
Hey, sir. Hey,
Hi,
sir.
Timmy.
Sir, please, can you repeat the question? For I don't really understand how to calculate them. I'm very lost there.
Okay. Do you know what the green lines are, Timmy?
I think it's isosceles.
There are isosceles, and more than that, the green lines are what we call a tangent. So if a line touches the circle in just one place, and it doesn't cut it like through the middle, we call these lines tangents. And so these two green tangents are equal in length. And so that's why we have an isosceles triangle. Does that kind of make sense? Or
Yes,
am I
it
still
does.
confused? Okay.
It does.
So now, because these are isosceles, and I know that this is 80 already, I take away 80 from 180 and I get 100. And this is what Joy J was saying. He was saying, look, if you've got 100 left and you have to share them equally between two angles, it must just be 100 divided by 2, and each must be 50.
Oh,
Does that kind of make sense?
yes,
Awesome.
it does.
Amy.
Thanks.
Thank you for your question. So this is going to be our last one for the day. Who can help me with getting to G? I feel like, is there anything from today that maybe can help me? Something from earlier in the lesson? I feel like there was something quite helpful earlier on. Yeah, Joy J, let's go to you. What do you think?
Hi again.
Hey.
From looking at it again, I'm seeing here there's kind of the line that is in G is touching the tangent.
Aha. So
And
this, are you talking about this line?
Yes,
What are you remembering?
I remember that, and it creates a 90-degree angle.
I agree with you. So what does G have to be then?
It has to be, let me calculate a little bit.
Cool. I think you're onto it though. I feel like I'm seeing what you're talking about. Like it's sort of hiding from us. But when you think about it, is there a tangent? Is there a radius? Yes. So it must be 90. It's just on the top. What do you get for G now? Oh, we've lost Joy J there. Can you hear me?
Hello?
Hey, I can hear you again. What do you think G is going to be?
I think G is going to be 40.
I totally agree with you. You have Hit it out the park. Well done. So G must be 40 because the other one was 50 and together they must be 90. So look at you guys. We're really doing some quite tricky types of questions. And so we're going to call it a day for today. So the two new facts that we learned about today, or the new theorems we learned about, were we learned that if you have a circle and you have a tangent, then the line, the radius meets the tangent at the point of tangency and makes a right angle. So that was the one thing we learned today, called the tan radius theorem. And then the other thing we learned today was that a tangent from a point outside the circle can make a pair of tangents, and tangents from a common point will give you equal lengths, or will give you an isosceles triangle. And the name of that theorem is just tangents from a common point. Now we'll continue with this in the next lesson, but I think that we've learned enough for today that we can do the poll now, and then I'll just answer any final clarifying questions. Lebo, could you put the poll out for the students so that they can have a chance to give us some feedback? And then are there any final questions? Just want to say huge shout out to all the new students who were like asking questions and giving their thinking. It really helps the class when everybody is showing their thinking freely. It really makes the class so much more like a community. So just a huge thank you to all, everyone particularly, but especially those students who were sharing their thinking. Are there any final questions? And then we'll just wait for the poll to come out. And if you could help us by letting us know in the poll how you found the lesson today, it helps us prepare and try and put the lesson at a speed that is the most helpful to most students. But it's always a balancing act. So that's why we need to get your feedback.
Thanks for all your hard work, guys. Please leave us your feedback before you disappear. We really appreciate it.
Absolutely. It's nice and quick online. Giving feedback doesn't take very long. Are there any final questions from the class? So I would encourage those of you who joined us for the first time today, have a look at the previous lessons, just so that you can start building up your knowledge. Vivian, let's go to you.
Hello, sir. Sorry again.
No, it's no problem.
But, for the second question that we did, there was one more question I had for that 90 degree.
Let's scroll up. Must I scroll up to that question? Have I got you there, Vivian?
Yes, sir. Yes, sir. You do.
Is it which one, number 2 or number which? Or number 2?
Yeah.
Okay, let's have a look at number 2. Where did I lose you?
No, I understood it. I just wanted to know if you could divide the 90 degrees. I know that it's the way that you did it was different. I just wanted to know if you could, or
divide it. You could. I mean, when you say divide, what do you mean exactly? Just so I can be clear, because I think I'm losing you on dividing it. Like, you can say 90 is made up of this one and this one. Is that what you mean by divide?
So what I mean is that after the acknowledging that it's 90 degrees, you divide that 90 degrees 2 because of the two triangles.
You wouldn't be able to divide it evenly because the y angle is bigger than the z. That's why you couldn't divide it into 2. No.
Okay.
Good question. Good question. All right, everyone.